Hi, we are Team Mimyk, so we work on medical simulation. My name is Shantanu. So I have a PhD in mechanical engineering and masters in same field. So the background is in robotics and controls and a lot of medical devices.
Hi, my name is Raghu, and my background is in design, and I'm helping the team here to put together the product. From the company.
Hi, I'm Nitin. I'm from IISc as well. So here we work on medical simulations, and a lot of the focus is on developing high quality simulations for medical practitioners. So yeah.
We also have another member, Balaji, who could not be here. He has experience in manufacturing and business, which he brings into the team.
Tell us about Mimyk. Yeah, I'll tell you guys about Mimyk. So Mimyk is this company which is incubated at the Institute of Science, and we incorporated sometime about August last year. We were about a year old, but the activities of this had started a long time ago as a part of Shantanu's PhD way back in 2012, and the team has been working together as this entity at least for the past 2 years. And so Mimyk, is different labs in IISc actually came together for this to happen. The main one, of course, is Shantanu's lab, the Intro-D2 lab in mechanical engineering, headed by Professor Anand Suresh, and Nitin's lab, the computer visualization lab at the Computer Science and Automation Department at IISc, headed by Professor Vijay Natarajan. It was basically a project which was funded by Robert Bosch Center for Cyber-Physical Systems, which is a center again at IISc. So they did most of the PhD work and funding for that, and when it came in from that center, it was done in these two labs. And post PhD, this was Shantanu decided to do a startup, and that's how we got together the team of Nitin and me and all those people. And so I bring in this background of design from the product design department at IISc. So that's the team.
So this is about how it started and things. So also started with a lot of clinical help from AIG, Institute of Gastroenterology, which is the largest center for gastroenterology. So we consistently we are always in touch with these clinicians, because what we do is clinical related problems. So the overall idea on what we are building is to make healthcare safe for everyone, make it more affordable, and improve the patient outcome. This is what we bring through our simulation capabilities that we have.
Mimyk has this core capability in this area of simulations, and simulations is like you basically model the physical world, and then you try to predict the behavior of that physical world. And Mimyk is trying to apply that sort of engineering or physics, applied physics capability to healthcare problems. And so the first thing that we are trying to do is to use simulations to train doctors, because we find that to be a sort of an easy entry point for us, because it's like a preclinical phase, so there's no certifications and approvals and all these things. We can enter the hospital, sell this product to train doctors and things like that, because there's no contact with the patient as such. So that's where we're going to use. We're going to enter this area, use simulations to train doctors, and that's going to be our first activity. And from there, we want to move on to more sophisticated clinical applications like patient-specific rehearsals, which is wherein the simulations are used by doctors to rehearse procedures before they actually do it on the patient. So that is our next thing. And from there, we want to go on to much more sophisticated things like visualization during actual procedures, and possibly robotics. So that's our That's what Mimyk is trying to do, and that's what our core capability is. And one more thing is that when we say simulations, we just don't create. It's not just a software, play, but it's actually a cyber-physical system wherein there's hardware and there's software and there's the user, and all of them interact together and create these holistic systems. That's what Mimyk is.
So one of the main benefits here is that there is the lack of healthcare professionals, especially if we take the use case of our first product, Mimyk, which is for endoscopy. The shortage of healthcare professionals in endoscopy itself is a big problem, because in India, about 30% of the population are affected by gastrointestinal GI diseases. So in that, because of that, the need for healthcare professionals is a constant driver. So towards that goal, we are building our first product, which will kind of impact in the training, as well as the next milestones for us are to develop systems which aid the practitioner, not just in training but also to rehearse this procedure, but also the larger vision is to get into the areas of surgical navigation, where the user of the device kind of gets a holistic idea of where in the particular patient the device, how it's being used. So it gives you contextual information about the procedure using without using complicated modalities like X-ray or live fluoroscopy images and those kind of things. So that is the kind of impact we're looking at.
Yeah, and also, from Mimyk perspective, so there are, doctors are doing amazing job, right? So, but our job is to empower them, give them the right tools through which they can go and do more, save more lives and things like that. That's what we're doing. Be it training or be it giving the right side of sort of visualization of their surgery and things like that. So it's all about empowering doctors to
So, for example, if you take the training simulator, for example, the endoscopy, a doctor might take a year or a year and a half before they can actually get the necessary skills to perform the procedure, on their own without supervision from a senior doctor. But through our simulator, we think that that time can be shortened, because they can play around with the scope and things like that without fear of injury causing harm to a patient. So that time can be extremely reduced. And if you take the rehearsal and things like that, it's just better planning. And I think since doctors anyway plan before doing a procedure, so they really would appreciate a better planning. Visualization is one amazing thing, because a good visualization, if it's there during the procedures, the thing is that the time for the procedure taken will come down, and that means the doctors can take care of more number of patients, and they fatigue less and things like that. So
overall, it's benefiting the patients, be it improving the outcome of their surgery or condition, or improving the safety of the entire procedure.
Because right now during visualization, what they do is they stand next to the patient and use X-rays to visualize. While the patient is exposed to X-rays is one-off, during the procedure, but the doctors and the staff in the operation theatre are continuously being exposed to this radiation. But they take that occupational hazard onto themselves for treating the patient. Of course, they wear leg suits and things like that, but still they do it. So that way, that's where we feel that if we can bring in these kinds of technologies, we'll really empower doctors to. We can take a particular example, but for example, you can take. If you want to take the example of this thing, explain the angio case.
Yeah. So what happens is when a patient has a case where some valve or stent needs to be deployed, is usually patient walks into the hospital and doctor takes a CT scan, figures out where is the thing, and then there is this team of doctors who come together and plan this, like the minimally invasive procedures. So these days nobody wants to cut open and things like that, just scars and things. So minimally invasive surgery is like preferred mode of treatment. So now they want to plan this deployment of stent or vial through these flexible instruments. So they're doing it with CT scans, which are like 2D data, and which is not giving that global perspective to them. And suddenly, with our technology, what they can do is we take the same patient-specific CT data, build a 3D model out of it, and load it into the simulators. Now doctors can see in 3D world where exactly they want to deploy the procedure. Not just plan, they can also rehearse. And now they can insert the this flexible catheter and rehearse or do a dry run to deploy that stent and see how it's behaving.
So that's dry run. They can do this dry run on your machine.
So this is the vision that we are working towards. Yes.
I would say on our systems, the platform, the technology that we are building is quite horizontal, and it can be applied to different specializations in the gastrointestinal, or it could be cardiovascular systems, or it could be other nephrology. Yeah, so all these. So whenever there is so right now we are, as our first case, we are focusing on a platform for flexible instruments, because we believe that's a much more complex problem to solve. And once we have done that, rigid instruments like laparoscopy and cannulation like needle and all those kind of things are much more simpler problems to implement once we have the base technology for flexible. Flexible instruments are like multiple small rigid legs. This is rigid tool is just one piece. The IISc's role is very vast, because all of us are in some way the alumni of the institute. Shantanu and Nitin did their PhDs here. I did my masters here. Balaji was staff in the lab. Shantanu was working. So IISc was the reason why the team came together, and this is where we picked up our technical expertise that was needed to build such a product. And so that is where IISc is this thing.
And IISc is also supporting in many ways in terms of research. This is a deep tech thing that we are building, right? So a lot of research help is coming from IISc, and SID is also helping us in terms of commercialization, taking to market, and in terms of business connects and things like that.
To start with the future plan, I think our first goal is to put the endoscopy simulator in the market. So once we have that, we would have entered our target customers, that's the hospitals, and from there we want to go into this area of patient-specific rehearsals, like I was mentioning, from the simulators into patient-specific rehearsals, because that is a natural progression for medical simulators. If you look internationally, the companies that are involved in making simulators are trying to move in the direction of patient-specific rehearsals, and so we want to move in that direction. And once we have this thing ready, we want to use our technology to start doing solutions for surgical visualization, because that's where then we start figuring in every procedure that's being performed in the major OT to start becoming a sort of an opportunity for our technology to impact. So that's our vision, and we want to. And one more thing which I would like to talk about, Mimyk, is that while all the technology we are developing is indigenous, so the access to we think that this technology is it will be accessible even to a country like India, because it's not going to be important. The technology is our own, and it's but that said, this is not what we are building. Is not really a import substitute. We are building globally competitive products. So we see our market India, but also the entire world. That could so once we enter the Indian market, we would at some point like to reach out to the global market as our future plan, maybe 2 or 3 years from now.
So VR, as we know it in its current form, everybody's used to seeing those the goggles and in immersive environment. And but the point of virtualization is to immerse the user and provide an experience which mimics reality in many different ways. And one of the other ways that that the users are engaged with reality is with sense of touch, which is a very important modality for sensing. And that is where we bring in a lot of innovation in terms of the haptics. When you interact with a particular body, what is the kind of forces that you feel, and why would you feel it? Does it match your expectations? Is it physically accurate? So that is where our background in simulation and simulation technology kind of brings in and ties in with VR, where we are able to give you a virtual embodiment of what the physical world might behave like in the context of medical simulations for both training as well as rehearsal. So yeah, that's kind of our expertise and focus in the areas of VR.